This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
All right, welcome everybody. I'm very excited that tonight I won't have to be doing a lot of the talking. Jesse from the regulators and the accelerators has volunteered to lead tonight's conversation. So I'm going to hand that over to Jesse. I'm also very excited. I was saying earlier when I jumped on the call was one of the best days. The best parts of my day today is when I checked to see the survey, and Jesse volunteered to lead tonight's conversation. Ian is going to lead next week's conversation, and Joseph is going to lead the week after that. So please, if you're interested in presenting a topic or leading a discussion, please, Lexi, can you post the link again? Lexi usually posts the links for that. We'd love to have other teams and especially students. So if you're interested in being a Dean's List candidate and you think that you've got a strong kind of resume for a Dean's List, this will just add to it. Or if you're giving a presentation at Jumpstart or something similar, you want a place to practice, this is a safe place to practice and get some good feedback before you have to do it in front of a live audience. So please, if you're interested, please sign up to lead a conversation or give a presentation on these Sunday night calls. This is by no means a Nightcrawler exclusive type of thing. We want all the teams to be able to take a conversation, take a leadership role, and take a shot at it. So with that, I am going to stop talking for a while. Jesse, the floor is yours.
All right. I'm here at the school and I'm in the shop, so I might be a little echoey. We're getting some rain, so you might hear that. I got my little four-legged helper here, and she likes to chime in once in a while too, but I felt bad leaving her at home, so she's with me. So tonight's topic is manufacturing when it comes to FRC and how different teams approach it a lot of different ways. Here at Cass Lake, we do a lot of our own, almost exclusively our own, completely our own manufacturing. We don't send anything really off. We don't have sponsors that can do that for us, so we're fortunate enough here to have the equipment to do it. But as far as the teams that are online here, how many of you guys do like 75% or more of your own manufacturing? Probably. Like, just give me a rough estimate so I know where to start. All right. Is that just affirmative, Eric, or is that a hand for a question? I'm going to go with hand for a question.
That's an affirmative.
Okay. Yep. So it can go from really little, and I just have a little list of like some hand tools that we use, some things that kind of make our lives easier throughout the season. Then we can get into a discussion on some 3D printers, mills and lathes that we have at our school, CNC routers, and then maybe a little bit of like funding to get this equipment if you desire it or you still need some of this stuff. We can talk about a few of those things. And if you guys got clever things, you guys let me know, because you might have something that I've never heard of and that I need to think about getting. So does that sound like a good plan? Yeah? All right. So I've looked at this before, and we've started acquiring a lot of this before we even I saw this stuff. But if you're not familiar, Spectrum, Team 3847, and you've probably seen it on Chief Delphi, they have a first 1,000 and a first 10,000. So if you were going to get into FRC manufacturing stuff, they have, I'll try to get some links in here. They have a list of kind of what would be their recommendations on your first X amount of dollars that you have available to spend. Pretty good, and actually, coincidentally, like the stuff that we've acquired over the years has been kind of right on par with what they think is probably what you should be doing too. So money comes in at different times, and to have some of these things on the back burner if you got a sponsor or somebody that says, I have $5,000 for you. But just to start off, I'll just grab some stuff and I'll bring it up. Just a good set of cordless drills and impacts. Once you pick a platform, stick with the platform, okay? Because then everything's universal. Don't have 2 Ryobis and 1 rigid and 3 DeWalt's laying around. Try to get something that makes sense for you. For the kids in the high school, I like these M12s because they're light and they do most of the work that you need to do with the drill. And Milwaukee is our platform. Some other things that we've acquired that are really nice. A cordless rivet gun. Amazing. So much better. You don't have to oil it. There's no hose. You need no air. And they work fantastically. Anybody can run one. Really good tool. Another one that we just got is a little electric stapler, also in Milwaukee. The bumper people were super happy when I got this. Stapling bumpers up. Works really nice. Takes the regular Arrow T50 staples, so it's pretty universal. Pretty heavy duty, actually. It'll go right into some pretty hard plywood. A portable bandsaw. We have another one too that's on a stand, the swag stand or whatever it is. This is the 18 volt version. It comes in a 12 volt version too. But rather than going, our robotics is in our automotive shop and we have a metal shop too. But oftentimes, rather than walking over to the metal shop to cut something on the big stationary bandsaw, we do it right here, right in the shop with us.
Hey, Jesse.
Yeah.
May I interrupt you for a second?
Yep.
So, for a newer team on the block trying to get these tools, would you recommend get the portable one or just get a standalone in your work, or get both? I mean, money is a factor here. Where do you think the dollar to be spent?
I would probably say a portable one if you're just gonna pick one, because then you can bring it to competition too and use it there.
Yep.
And if you're careful about your setup and you have a good vise, you can cut a pretty straight line with a portable one with a good blade. But you can get like a Jet or even like a Harbor Freight non-portable one for relatively cheap, probably actually cheaper than the portable one from Milwaukee.
Okay.
But yeah, a good bandsaw is pretty crucial to making nice square cuts and
All right.
yeah.
Thank you.
We got a couple of these. It's a little brushless cordless vacuum, 12 volt. So when you're cutting that stuff with the bandsaw over your robot, you can suck up all the stuff that's falling off of it. Nice little tool too. So beyond that, I mean, those are some cool power tools that we have that make life a lot easier. You're not running back and forth to different locations because you have air over here and not over there, or you have certain bigger electrical components in one place. But and these things all travel with us, so the kids are used to using them during the build season. They travel with us to the competition, so they're familiar with the tools that they're using in the pits. They're the same tools that they use when they build. Some other little things. Once you get into trying to do some precision manufacturing, you can get these at Harbor Freight. All that's going to come through. It's a little spring-loaded center punch. Okay, they cost like $2. They last about a year, and you throw them away because they stop working. But as far as getting a spot, if you're going to hand drill a hole, having it so the drill doesn't wander, something like that is really nice. A little deburring tool, especially if you don't have a real shop that you're working out of. You're probably not going to be using a belt sander in the classroom if you're working out of a classroom, but it takes the sharp edge off the aluminum things. We use this every year and frequently. It is a hex broach, 1/2-inch hex broach. And what a broach does, for those that don't know, is you drill a 1/2-inch hole in something, you press this through, or you can even tap it through with a rubber mallet if it's thin aluminum, and it turns your round hole into a 1/2-inch across the flat hex hole, used for putting shafts through and things like that, or maybe putting some clearance into some wheels that fit too tightly, or a lot of different things. Kind of an expensive little thing, but a pretty useful little tool.
Jesse, where did you get that brooch?
I've got that one from McMaster-Carr, but you can get them from Andy Mark too. And I think Andy Mark probably sources them from McMaster or the same. This is a Minuteman, Dumont, USA made. You can get a Chinese made one too. They're fine. I mean, you're not broaching real thick chunks of steel. I've had this one for years and years, and it's still sharp, still works good. You just gotta make sure the kids don't drop it because it's kind of like a file. It's super hard, and it'll fracture or even shatter if it's dropped on something hard. So, or if you hit it with something hard, rubber mallet, not a metal hammer, to drive it through something if you need to. To kind of go along with that, you can get these at a Northern Tool or a Harbor Freight or anywhere too, but it's a little 1/2-ton arbor press. Pushing in bearings, like, don't beat them in with a hammer, use an arbor press, even pressure, and that'll work with my broach as well, if you have kind of the right blocking set up underneath there to push the broach through. If you don't have a hydraulic press, a little arbor press is a nice little tool. You usually get a voucher from, I don't know who does it, Automation Direct maybe, and a couple other people, but a good step drill that goes up to 1 1/8 inch. Get a couple of them because they'll get dull. But if you're doing a bearing hole and you're really careful, you can do this with a hand drill and have a pretty good snap fit on a bearing hole with a step drill, a good step drill. I'd recommend putting it into a actual drill press to do it, but if you're careful, you can do it by hand. And the other thing, if you're getting into some manufacturing stuff, and I'm not going to open it up. This is an Irwin brand, standard, non-metric tap and die set. Rethreading holes or threading those 1032s or 1/420s that you use all the time. Having a good tap and die set is nice. Comes with different handles. I would recommend probably buying multiple of the common ones, the 1032s and 1/420s. But yeah, having a good one of those is a nice option too. So those are just some of the things we got. We got a bunch of other stuff too that we travel with, but those are some of the more unique things. I don't know if anybody else has something that they really love to use that is crucial to how they run that they want to share.
I have a question.
Sure.
Because I've been looking for a drill press for our team. We are in a basement, so you got to be mindful of what you're buying, because of weight. But sorry, my kid is watching. My question is, what is a good drill press that is a bench top, drill press? Because I figure with a bench top drill press, it will be a little easier to carry down 2 flights of stairs.
I guess brand wise, I don't know that I'd necessarily recommend anything in particular. If you can get a little benchtop one with a variable speed, that'd be kind of cool instead of having to change belts and stuff.
Is that a size recommendation?
Horsepower wise, I don't know. You're going to be in a basement. You're going to want something that obviously runs on 110 volts. You don't want anything bigger than that. Otherwise, I mean, they're not going to be bench top if they're running more than that anyway. But I guess I don't know motor wise, horsepower, what you really need. If it comes with an adjustable base, if it comes with a chuck, especially like one of the keyless chucks would be good. Like I said, variable speed is kind of nice when you're dealing with different size holes and step bits and stuff like that. You want to be able to really slow it down. And if you're drilling big holes, you want to be able to crank it up. So I don't know if anybody has a good brand recommendation. I'd find one that's in the price range and has a few of those little extra goodies with it and go for it, I guess.
Is Eric hand up? It's been up for quite a while. I'm just wondering if he has a question or he just forgot.
I think he just forgot.
That was just for your first question.
Yeah.
I don't know.
Yeah. Scott was saying they just got one of those cordless riveters. Yeah, they're super nice. You're going to love it. You're going to wonder how you even lived without it. And then, yeah, the hex broach for fixing 3D printed parts. If they print a little tight, yeah, we use it a lot for that too. And it goes right through plastic. Super nice. You'll wind up with a fit that'll just slide right onto the Thunder hex stuff. Any kind of half-inch hex shaft.
I have a Nightcrawler bought a new tool last year, and then we didn't even end up needing it for last year's robot, but we're kind of excited about it. We got a acrylic, acrylic PVC plastic bender, so you can heat up your polycarb or anything plastic and then bend it on a really nice straight bend. It basically is just a heating element, and you just lay your plastic on this heating element, and then it melts or softens the plastic in that spot, and you can bend it straight. And you could probably freehand it, or you could use it with like an aluminum bender, a brake type thing. And the one that we got is even water cooled as well, so it's sort of safer on the edges. But that was kind of been on our we should do that list, and then we finally did end up buying it last year, and then our robot didn't need anything that needed to be bent, so no polycarb. So, but that's a neat tool that we've only heard of one other team that has used them in the past, but we're looking forward to getting a chance to use it.
Yeah, we have one here too as well. It's just basically a metal box with a heating element that runs through. A couple straight edges on each side is ours, and then you just lay your piece over it. Kind of mark your piece out where you want that heat to be concentrated. I don't know if yours sounds a little bit fancier than the one we got, Scott, but yeah, it works good, especially with acrylic. I mean, if you're bending polycarb will kind of form for you a little bit. Acrylic's just going to instantly snap. So if you're using acrylic on anything, then those heated ones are pretty cool. So that's kind of the hand tool stuff. If anybody else has anything, I'll give it a second or two here. And then I was going to kind of transfer into something that probably a lot more of us have had an opportunity to use, and everybody's probably got some form of it, which is some 3D printing stuff. Okay. All right. If you think of something later on, let me know. But so here at Cass Lake, we have an Ultimaker S5, which I like quite a bit. Not a cheap 3D printer, but it's a nice 3D printer. And then we have three, they're called Affinias, which I would not recommend people buy. They're kind of good for like trinkety type of stuff. They don't have any dissolvable support media options with those. And the platform on those is really pretty finicky. You got to be pretty careful with lift on bigger parts. The S5, you can print that whole platform full of material, and I've never had it even come close to thinking about lifting. It's been flawless. And another thing I like about the Ultimaker is, although their media is not cheap, they have a lot of different kinds. Typically what we use is they call it tough PLA. And it usually is pretty robust. We've broken some stuff, obviously, because we 3D printed parts that probably should have been made out of metal. But, ooh, she's excited. Some of the things that we've done are, I think a lot of people are familiar with these. They're on Thingiverse. They're called height blocks. And they basically clamp over a 1x, or you can get the 2x1 size. This is 1x1. And then they have the bearing hole and then the sim hole mounts. This is not designed by our team, but we utilize it a lot for prototyping and even on competition machines to hold shafts. If you want to raise it up a half an inch to prototype it, you just loosen it and it slides up instead of having to drill more holes in whatever you're using. But these height blocks, and this is just printed out of that tough PLA.
Could you send?
3D printer do you have?
What's
How
that?
large- How
Eric?
large a part can you do on your 3D printer?
I think it's a 10 by, I think it's almost 10 by 10 by 10 on that S5. Somebody could correct me if I'm wrong, but it's pretty close to that. So you can get, I mean, we've never printed anything that big for anything that we've done. But you can print multiple of these at the same time. I'll see if I can find that height blocks link. Yeah, here's the Thingiverse link for it. And they have a bunch of different types on here. Some of them are for like old motors that nobody uses anymore. Their mounting structure, but they have some for 775s and some for the Sim Neo Falcon bolt pattern. And I can't remember what team does it. What team came out with that? But it might tell. 5254 was the team that created these a few years back. And I think it's the same team that does these little guys, which is again a clamping thing. And this is for a 1x1 again. And they come in 90-degree, 45, 60-degree angles. So if you just have two pieces and you don't want to gusset it, you can use these clamping 3D printed deals. If you want to put bolt holes through, you can if it's a pre-drilled piece of aluminum, or you can use it as a drill jig, actually, I suppose, if you wanted to. But again, for prototyping purposes, instead of riveting on gussets and drilling out the rivets and riveting it on somewhere else, you can use these kind of things. That work pretty good. One of the things that we've been experimenting with for the last 2 years, probably, with that Ultimaker is printing in TPU, which is a flexible material. So here's a pulley for a wide belt, like a 1.5 inch wide Vex rubber belt. The Convex pulley? I don't know, whatever it is. But here's the rubber version. We just tried them to see which one was better. And in our circumstances, it really didn't make a lot of difference, but this has some pretty good squish to it. I don't know if you'll be able to see that, but that's all depending on your, yeah, he's got some stuff right there. Ian does. Yeah. Depending on your, that's really heavily dependent on your infill. So if you're doing like a close to solid or solid infill, this is not going to give much. But if you do like a 20% infill or something like that, it does have a lot of give, and it can be useful. We actually printed some little, like the 1.5 inch with the hex bore wheels. So we didn't want to buy any. We just printed a few to see if they would work for a thing last year or 2 years ago. But yeah, I mean, they're not as squishy as like the green compliant. They're probably more like a blue or black durometer, I would guess. They're not as grippy either. They're a little slicker, but anyway, you can make your own if you want to, depending on the 3D printer you have, if it has the capability of printing in a rubberized.
Yeah, and the hardness also depends on the durometer of the filament you buy. So like if you buy 95A or 90A TP, which is the common thing you'll find, it'll be harder versus this is made out of NinjaFlex, which is obscenely expensive for not much. But it is like really, really flexible. And it's less obscenely expensive if you buy the glow-in-the-dark filament, which destroys your not all-metal hot end. And so it ends up costing me in the long run anyways.
What kind of printer are you running? Yeah.
I'm running a really terribly Frankenstein Ender 3 Pro. And it has a Ender 5 direct drive on it. Because it was on sale, and then it's like a terrifying machine at this point with how it's very janky, and only works about half the time, but when it does work, it works pretty nicely.
Anybody else have recommendations on printers? Or, well, like I said, I like my Ultimaker. I don't like my Affinias. I don't have much experience with other ones.
Nightcrawler has an Ender 3 Pro and an Ender 5 Plus, which we're trying to sell if anyone wants a massive printer. We did not think about how much space it would take up when we bought that one, but it's a 300 millimeter cube printer. And then we also have a Prusa. We have Prusa 3, and then I personally own a Prusa 4. I just got. We print a lot of stuff on the Prusa, but we also use the Ender 3 as well. The nice thing I like about the Prusa, it has a direct drive, and the Prusa 4 has a very large drive gear. I really struggled to get Flex to print. TPU and TPE, I had a lot of trouble getting Flex to print on my Prusa 3. And I finally figured I just had to slow down. So if I slowed down the print speed, then I had a lot more success. But on the Prusa 4 with that larger drive gear, and it's a direct drive like Ian was saying, the drive is right next to the extruder. That Prusa 4 with the large drive gear, it printed with the factory default settings right out of the box the very first time I tried. It is set up well for doing soft filament.
Does anyone here have experience with the Bamboo Lab printers?
We just got one on Nomatech, and we ordered it, and we're really excited because we got a grant for it, but we haven't tested it yet.
I would really love to get your feedback on how well it works, because if it lives up to the hype, it's got to be an amazing printer.
Yeah, they're supposed to be crazy fast, aren't they? Just their travel speed and their how fast they can put down material. Yeah, I'd be interested to fire that thing up, man. Let us know how it goes. I want to know. How much was it? Do you have any idea?
It was, I think, $1,500, so definitely quite a bit pricey, but we got a grant for it, which was really nice.
Yeah, and I think the base model is $700, so it's comparable to a Peugeot Mark IV. And I think it has about the same number of features, give or take. They're roughly comparable.
So I got a question for you for these nice fancy toys. Where would a guy who wants to play with stuff like that on his team go to find a sponsor or a grant that will pay for stuff like that? Is there anything out there?
I think any sponsor, sponsors are sometimes pretty flexible on how you spend the money they give you. So I think they'll probably would be okay with that. If you, like for us, I'm a shop teacher, and a couple of the other coaches on the team are also in the district. A couple of us have CTE licenses, so career and technical education licenses. And a lot of our big equipment was purchased through those Perkins. It's called Perkins dollars. So I use them in my classes too, but then we use them with the team as well.
For $39.26, we don't actually have any 3D printers that belong to the team. Whenever we do 3D manufacturing, we generally have, our school has like one 3D printer, but it's not the greatest. And so we generally rely on team members. So I have a printer in my house. And then we have a member who has a Prusa Mark III, I believe. And so we've generally gotten away with just utilizing those two, as well as our sponsor 3M has printed a few things for us, like that really big battery mount that we have on our robot. I don't know if people have seen that or seen it in our CAD. Probably like only one person in this call knows what I'm talking about. But we generally kind of just outsource all of our 3D printing, which has been fairly fine, I would say. And it's wonderful for the team. It's probably not wonderful for me when I waste a roll of TPU filament on star wheels to put on our intake. But you know, that's robotics sometimes.
If you're looking to tiptoe into 3D printing and you or one of your students has a lot of patience, you can usually pick up an Ender 3 for $100. Micro Center, they have a location in the Twin Cities, but you can order it and have it shipped. They oftentimes once or twice or sometimes more than that a year.
I think it's year round.
Cyber Monday, Black Friday type sales too. And I think Amazon even did this last year, where they were selling the Ender 3 for $99. And you know, it takes some patience, it takes some tuning to get everything dialed in correctly. But for $99, I mean, we have parts on our robot that have been printed on an Ender. The thing I like about the Prusa is that you put it together and you run through the self-check and you just print, and there's almost no tuning to it. But you're paying almost $900, you know, for $99 with a little bit of patience and fortitude, persistence, you can get out some pretty decent prints on that. It's a good place to start anyway. But again, it takes some time and patience to get it dialed in.
I'd also say it's a really good learning experience having one, because I used to do prints on the school printer, which generally, you know, most of the time just worked, or, you know, some other printer that just generally worked. And I didn't really have an understanding of the mechanics of it, of you press print, filament comes out, you know, congratulations, you have your part, versus I think for the Ender 3, you gain a better sense of appreciation for what goes into it. In terms of, by the time you've had it for a year, you've probably taken it apart, you know, a couple times, because every time, you know, either something breaks and you have to fix it, or you're like, I want to upgrade this. You kind of end up just tinkering with it a lot, which I think helped me learn a lot more about, you know, what the 3D printers are doing, which in turn helped me create better prints, because I understood, you know, what's causing the print to string, what's causing, you know, all of these issues that I'm seeing on the prints.
Talon's had a good relationship with Stratasys. We have an ancient Stratasys machine that often breaks, and they will repair it, but we might have to wait months for that. Otherwise, our students do a lot of their own printing. And then if we have something that's way too large for us to print, Stratasys will do it for us. Or if it's some very special materials that nobody else has, they also have been good.
Has anybody ever used any of the carbon fiber reinforced stuff? That's something that I'm not even sure if my printer will take it, but it's intriguing.
3926 did it for our 720 degree turret gear in 2022. So that entire gear on the base was printed on one of our mentors printers that did carbon fiber reinforced. And then we also printed the hood of the turret that did not make it past week 0 on that. The hood had some design flaws with it that caused it to not work as it was intended. And it's generally, I mean, that gear held up throughout the entire season. and we didn't see many issues with it. Although I think it is, it's pretty big pain to print out of it unless you have either a sponsor who can do it or a mentor who already has the printer set up and ready to do it.
Ben, you have a comment or a question?
Oh yeah, I was just about to say that we on our Prusa have printed it's inland carbon fiber, and we've had pretty good luck with it. We do have a hardened nozzle and an enclosure for it, but with a little bit of diligence, we've gotten some pretty good parts.
Does anybody use any of the companies like I don't know what it's called, but there's like a sand kind of deal, but only in the 3D printing realm, like where you send it off to a farm and send your file off to a farm and then they get it back to you? Anybody have any experience with that? No. I know there's.
I personally don't have any experience with that, but I know Stratasys does that a lot for Minnesota robotics teams. I think they do it a lot with First Tech Challenge teams. Those teams, especially teams that don't have 3D printers, they send a lot of parts to Stratasys. And as Stratasys' sponsorship of High Tech Kids, they actually allow First Tech Challenge teams to send in parts and then get them printed for free for the season. So I know they're a great local company that does that.
Cool. Anybody else got any interesting 3D printing stuff? Here's a one that we just did on MK4, not the eye, shroud that we just did. I don't know if we're going to use it or not.
Question. So, what would be your advice to a relatively new team? Do you think that's something we should spare our dollar, not go into it, or is that a good place to start? Considering my kids don't really. I actually have one that actually has a 3D printer, so he might be the one that might be tinkering with that a lot of the time. So, I thought maybe get one, so to give them another reason or something else to tinker with, even if we don't use it for anything useful on the team necessarily initially, but down the road, maybe as a skill set that the kids can learn, something else to put under the belt. Any opinion on that?
I would agree that it's probably a great tool. Even if it doesn't end up with a part on your robot, it might encourage several of your kids to dig into CAD. Learning Onshape is one thing when you're trying to design a robot and you're struggling with how to figure out how to get aluminum tubing to connect, to a shooter shroud or something like that. But if you can CAD up and 3D print something to show your friends, I feel like for some students, that's going to be a motivator for them to dig in and learn CAD. So if that's all that you accomplish with is they design something that they print for fun, that's still probably a good skill set to build for your team.
Thank you.
Yeah, I would agree with that. A lot of the stuff that we print is just prototype purposes or just kind of for fun stuff, and I use them for classes too. But getting kids, even if it's the littlest, tiniest little bracket that goes on the robot, they can be like, I designed that and I made that. So it's kind of cool. Could be.
Do any of the teams use SolidWorks?
We do not.
We used SolidWorks for years, and then the pandemic hit, and everybody was doing stuff from home, and we transitioned to Onshape. Some of our kids stayed in SolidWorks. Most of our kids didn't have a computer that could run it from home, so we transitioned to Onshape. And the collaboration is so much simpler in Onshape. We just kind of all switched over to Onshape at that point. So it's a lot easier to rather than using GrabCAD and, oh, I forgot to upload my version, and then you've got conflicts and all of that stuff. The Onshape has just made life so much easier for us.
Okay, we've stuck with SolidWorks. We have a computer we use in our room that we teach on and share, and do the entire robot is all run on SolidWorks or designed.
And on Nomothic, we're similar to Nightcrawler there, where I think starting the 2022 season, we switched over to Onshape, and it's worked out very nicely. It also seems a lot easier to learn, at least for me. I don't know.
Right now,
One skill that SolidWorks gives you is a step up on industry, because it is an industry standard, and if kids learn it in high school, then it's really nice to have on your resume.
Yeah, I'll second that. My son is an engineering student at UW-Madison, and they're exclusively SolidWorks. But I feel like if you learn one CAD tool, the transition's not too terribly bad. I will say that he had an internship and they did AutoCAD. So he did engineering designs all in AutoCAD or I think it was AutoCAD. And he felt like AutoCAD was easier than SolidWorks, even though he has done SolidWorks for 2 years in school. And I will say that I agree with you that I think Onshape is easier than SolidWorks. I mean, you're not going to get stress features and flow laminar dynamics and all that business that SolidWorks gives you, but most teams aren't doing that anyway. But you gotta do what works for your team. If you love SolidWorks, then you should definitely use it.
And I do also want to say, I know one of the sort of downsides that Nomothic has seen is like running CAM files, which I know that gets a little bit more but Onshape, at least we haven't found a very good CAM software there. So I think we're using Fusion 360 for CAM this year. And we're going to see how that works.
That's also what Nightcrawler does, is we export the step file and then we load it up into Fusion and use that as CAM software.
yeah, 3926 also has been transitioning to Onshape. We used to use Fusion 360 for both CAD and CAM because we liked that it was integrated. But with Onshape, obviously, we can kind of just integrate. It's so much easier to just share ideas, especially because having been on the Open Alliance last year, where all of our CAD was public, it was easier for people to just be able to access that by clicking a link and opening what might as well be a Google Docs, but for CAD. And in some ways, it's been helpful. There are still a couple members of our team who are resisting switching to, or pushing back, I guess, on the switch to Onshape because they really like Fusion. So what they've been doing is they've been CADing in Fusion and then uploading to Onshape, and we've been downloading it from Onshape. So it's been, this whole thing, but it seems to be working fine-ish.
Has anybody ever used the Pro Onshape version? I think there's a little bit more of that collaborative sharing ability with that, or maybe it's not even worth exploring. I don't know. No. Everybody.
The one thing I will say that I love about Onshape the most is the versioning. I love being able to mark a version of, I'm going to do something really crazy. So I'm going to make a benchmark of where I'm at in case I screw everything up. And then I can go back to that version. As a software developer, in using Git and GitHub with the versioning and commits and things like that, it feels very natural to me to sort of make that benchmark of, okay, here's where I am when this part was working. And then we've had situations before where we open up the document and suddenly our mates are gone or missing or something like that. We don't know what happened, and we would go back to a previous version and fix up the things that had changed since the version was made. But the lesson we learned is make versions often, make versions every day. Every night when you're done at robotics, make a version so that you can kind of benchmark where you've been. And that's a good tip for using Onshape.
The other real cool thing about Onshape, if you haven't used it, and we teach Autodesk. Autodesk Inventor is taught at our school. So we got some kids that are somewhat proficient at that. And we use that a little bit too. And all kinds of various CAD stuff. But just the libraries that you can get from Onshape, like the MK library, like there's every part that AndyMark, Vex, Rev, every part that they sell is a library file. And you just drag it and drop it, which is nice to see how things fit together. And if you're doing some really cool 3D rendering stuff, I mean, you got all the components there that you don't have to remake. So having those libraries, which aren't really available on AutoCAD, and I don't know how available they are in SolidWorks. All right. So we were kind of on to 3D printers there. Now I was going to move on to some of the bigger stuff, which is going to involve me moving around. So we'll see this. But one thing before I leave, we just got these on the suggestion of somebody. So if you're running Swerve Drive, one of the important parts is lubricating those gears down at the bottom there. And you can put that red tacky grease on your fingers and then rub it all over the gears. And we do it like every 4 matches probably. But we found these little dental syringes. If you just fill them up with grease, we just squirt it on there. And it automatically greases itself and your hands are clean. It's amazing. Yeah, go ahead, Ian.
So is there a recommended amount of like how frequently we put grease onto swerve wheels? Because I know we haven't re-lubricated since we did our original greasing.
Yeah, I would say you're beyond the recommended. I don't know if what are you running? Are you running SDS or
SDS Mark IVs?
Oh yeah. We like I said, we do it about every 4 matches worth of time. The grease, I don't know who was telling me this, but somebody that I thought knew what they were talking about was saying that the grease should, if your bumpers, the inside of your bumpers don't have grease on them, you're not greasing them enough. Like it should be flinging grease off onto the inside of your bumpers. So, and I've seen those gears just straight up fail because they got too dry and they started wearing out. So, yeah, it's an expensive component. I'd rather have it a little messy than break down and have to replace stuff. So, we grease ours a lot. So I think what I'm going to try to do here, and Scott's going to have to let me in, I'm going to try not to get any feedback with the deal, but I'm going to go in walking mode so I can show you some of the other equipment. If you guys want to talk about some of the router or the mill or the lathe and that kind of stuff, and I can kind of go over what we have here and how we use it. So
sure. Yeah, I can let you in. Just probably mute your computer so that you don't get that feedback.
Is it popping up, Scott?
Not yet.
Oh, yeah.
Yeah, I haven't seen anything come on yet to join.
I'll try it one more time here. Maybe it doesn't like that I'm on 2 at the same time.
Well, I'm on twice. There you go. It says you joined.
And now you can hear me, right?
Yes, that's working.
So if you haven't seen one of those Ultimakers, I'll show you what we got. And they're an expensive printer. I think we bought a few years ago, but I think it was like $3,500. But it's got the 2-print dual core, and you can run whatever. I got a dissolvable and a tough PLA in there. But you can run 2 different colors or whatever you want there, just a glass bed. Never had a problem with anything ever lifting, no matter what I printed on Doesn't matter the material, it just doesn't care. It does have an integrated webcam. I don't run any of my stuff through our school's internet stuff because it turns into a disaster. And I don't want the English teacher trying to print to the Ultimaker printer with his packets of material or whatever he might have. So that's that. One of the other things that we have that we don't really use for manufacturing, I guess I wouldn't say, but we do have a Cricut that we do a lot of our, the bag of Cricut there. We do all of our sponsor logos and stuff that go on our robot with our Cricut machine. It's gonna get just a touch noisy in this room for a second until I shut it off. We do have a laser engraver cutter. Obviously not a metal viable one, but it's a pretty large format one. It's an 80 watt. It'll cut acrylic beautifully. Polycarbonate, it just melts and turns into very toxic vapors that don't look good. But if you're doing like prototyping out of wood or something like that, a laser cutter engraver is nice. And we do a lot of other promotional stuff for sponsors and thank you plaques and things like that on that. But as far as like buying one for FRC uses, I don't think I think that would be very low on my list of things to buy, probably. Routers. How many people have some sort of CNC router that they use? All right, what do you guys got?
Nightcrawler has an Amio 8 in our that the team owns, and then I have a Shapeoko XXL, and Ben, who's on the call here, he has an X-Carve. So between all of those things, we can usually get stuff either made at a meeting or in between meetings.
Yeah, that's awesome. This thing really changed our game, and it doesn't really matter what kind you get. This is a pretty large one. It's a Velox, who is no longer in business. 50/50 with VFD spindle, which I would highly recommend, as opposed to the old school hand router mounted to your machine, which is obnoxiously loud. You can actually be in the room when this thing's running, and it's not terrible. One thing that we found that when we started using it though, is that when you're cutting aluminum, which most of us probably are, polycarb's no problem. Anything will cut polycarb and it won't care. Same with wood. But aluminum tends to be sticky when you're cutting it. So having for sure some air and maybe some kind of liquid helps a lot. I don't know, you guys, Scott, you guys run yours dry or you use something?
I run mine at home dry, but we have we have an oiler. We run alcohol on the Amio X8 at school.
Okay, that's just like an isopropyl type of stuff.
Yep.
Okay, we got this, and it's kind of a mess. And that Omnio has a aluminum bed, right?
Yes, it does, but we put a wasteboard on it so that we can cut all the way through our sheet aluminum.
Yeah, I think we have a HDP wasteboards on there. But what we use on this one, if you have an MDF bed, which a lot of routers do, or some kind of wooden bed, then I would use something like Scott uses, alcohol for sure. But water's free, and we got one of the what's it called? Fog Buster, Mist Buster, Fog Buster. Anyway, it runs off shop air, low pressure, and then out the nozzle. Fog Buster. It's just a mist. It's not droplets of water, so you can still get some pretty good cooling and lubrication, and not have like a huge puddle on the floor when you're done. Just a couple shop breaks to kind of contain it works pretty good. So yeah, being able to make parts with a router totally changed our team's competitive level. This the single most important piece of equipment that we probably use to make really good stuff. Finding an aluminum supplier was crucial. We actually have a sign company that they have all these polycarbonate signs that they throw away every year. I don't know, it's like a gas station one. It just lets us dumpster dive out there and grab the stuff, and it might have some weird words on it, but I don't really care. You can paint it or do whatever after you're done with it, but free polycarbonate. Yeah, there's some more. And then for this one, we use, for our cam, we use Velux V-Carve Pro. Cut 2D Pro. Actually, this is a 2.5D program. We do have a 3D software for a different router that we have in the wood shop, which is the same. Not Velux, what am I talking about? V-Carve. And then this one's run by a Mach 3 controller, which is pretty common for sort of generic-y type of router stuff. But I'd like to hear a little bit more about what you guys are using, because I know this thing's nice, but it's kind of big and sort of clunky, and I wouldn't mind trying to get something on a smaller footprint that's a little more comfortable for some kids to run. Wherever, I got 3 hands up, so somebody just go.
Yeah, since you said footprint, that's kind of what my question is about, since you mentioned footprint. So I think I would like those two polite young men. Wait, just kidding. So how much space do you need to have around for a good CNC router? So, like, when I mean good for a beginner, good for, low budget, small town school, because that's one of those things that we want to get for our team, so I can stop bugging you, Jesse.
I've made some parts for Jeremiah in the past, and I've made some parts for a lot of different teams, but probably that Omnio, like you have, Scott, would probably be a good option for somebody just getting into it on a budget, I would guess.
Yeah, I think
Ben's on the call, and Ben has become our CNC expert for Nightcrawler on the Omnio. It is very affordable, but I get the impression, and I love Ben to talk about this if he's listening. I get the impression it takes a lot of patience, and the Mach 3 software, Jesse, it sounds like you're running Mach 3. Sounds like that's been sort of a not terribly intuitive piece of software to make a machine do something. Maybe Ben's walked away for a moment.
No, I'm here.
Oh, there you
are. We had a lot of initial trouble setting it up. We followed the West Coast manual, and we actually set up Mach 3 with their West Coast overlay. And there were just things that they kind of didn't talk about, like jogging properly and setting up that you have to put a feed rate in for it to actually jog properly. So they're just a bunch of little things that made it really hard to get started. We've pretty much got it dialed in now. We had help from a former student alumni. He came in and helped us do some work on tool changing and setting up so that we don't have to, remeasure Z. We have a touchpad that touches the tool off, and it applies an offset for that tool, so we don't have to go back and measure and re-zero every time we change a tool. So it's a cumulative process. As for amount of space, I was trying to look on the Onshape and find our drawing, but so we just built a cart for it. We store it underneath one of our shelves. It's probably about 3 feet by 4 feet. You can if you have like a bench top, you can probably get it in a smaller place, but we just wanted to be able to move it around the shop and get it. Sorry, go ahead.
That seems like my kind of workspace. It's we have a closet that we store things, but in the general area we work, we can't just have things sitting around, and so that's gonna, you know.
Yeah. Other than what Scott said, we set it up to mist with the alcohol because of the MDF waste board. And we cut quite a few of our parts last year on it. And we're looking forward to cutting more. If anybody has any other questions, I'm happy to answer them.
Yeah, 3926 in terms of our CNC capabilities. We have a shop bot in the lab, which is pretty overkill for what we use. We got donated when a makerspace near us closed down, and that was in 2019, I believe. And then in terms of what I can speak to, I blew a bunch of the money I earned from reffing youth soccer for a while before I got a different job on a Shapeoko 4 XXL also. That one's been causing me some headaches. And it takes a lot of patience to get the speeds and feeds right, at least from my experience. Because what I've been using it to do is dialing it into, I use it to create turntables for this board game called Dominion I like a lot, and the goal is to sell them. And so I've been working on that, and the Shapeoko 4 has definitely caused a few headaches in terms of the belt skipping has been my main issue with them.
I have a Shapeoko 3. I think it's a 3. And it's not super fast. I mean, the Amio is going to be faster, and it's not cheaper. But I tell you what, I love their support. I've had I ordered an upgrade part, and they sent me the wrong part, and the guy talked to me for half an hour just about robotics and said, "Oh, let me send you that part that you need isn't one we actually normally sell, but I'll just send it to you for free, no problem. Here it is." I've been paying attention. I posted it in the chat here, but the new Shapeoko, they have a new Shapeoko that has a water-cooled spindle. And so I'm guessing the model that Ian and I both have just use a hand router, which Jesse was talking about in terms of, monkeying around with that hand router. It can be kind of tricky. But the new Shapeoko has a water-cooled spindle. And I think if I had to do it over again, I'm happy that we have the Amio for robotics, and the price that we paid for it was definitely within our budget. But if I use my personal Shapeoko any more than I currently do, I am actually spring to buy this one because I like the brand. And this one has lead screws everywhere too. I think there's no belts anymore, which solves a problem that Ian was talking about. But feeds and speeds are definitely hard. And I don't think it matters what type of machine you have. Getting the right chip load, I guess. I've watched tons of YouTube videos, and I've seen all these things about formulas and everything else. And the most helpful video I saw was a guy who said, "Stop worrying about feeds and speeds. All you need to worry about is chip load." And so they talk about getting the right size chips out of your aluminum plate or out of your polycarb so that you're taking the heat away from your material. And once he started said, "Look, just run out of speed and then crank the speed up. Go faster, go faster, go faster, and until you get your chip the size you want. And if you're taking too big of a bite, you'll know because you're going to start to chatter or you'll break your end mill." But yeah, that's one of my things of like, I need to go out and cut the same part 50 times to try to dial in my optimal speeds. And I just haven't taken the time to do that.
Yeah. And I think it's trickier with the Shapeoko just because you can't just focus on the chip load because of it being a less rigid machine, at least from my experience, where it's like you can have the optimal chip load, but if you're still running it too fast, the belts are going to skip or it's going to get bogged down into the wood. And at least I've had trouble with that. But Carbide 3D support is super incredible. I've had nothing but really good help from them, and like it's just, I think that's the best customer support I've received from any company ever, in terms of, needing help. Like even when we were deciding what bits to get, I just emailed Lemons like, what bits would you recommend for doing this? And then they were super helpful in, responding back, for just about everything.
Yeah, I agree. The other tip that I had, if you're running out a hobbyist machine, kind of like what Ian and I are using, is to use a single flute end mill, because you have to go slower because you only have one cutting blade, where if you have two cutting blades, you can go twice as fast. And so on a machine, a hobbyist machine, if you're getting a benchtop machine that doesn't have a very powerful head, you can use a single flute, and then you have to go slower because you only have one cutting blade, but then that solves some of the precision issues you might have by going too fast. You have to go fast enough that you're getting a big enough bite. Otherwise, you're going to melt your aluminum because you're not taking a big enough chunk and there's too much heat going into the material. And so to be able to go fast enough, but not so fast you start skipping your machine, you can try going down to a single flute, also called an O flute end mill. And that can help some of your problems on those lower powered, lower end machines.
Yeah, I think part of my struggle right now is I've been trying to get away with just running a 2-flute compression bit, which means I have to get a certain depth for the compression bit to actually do its thing. But that means I'm, pushing it pretty hard, and that means I'm running it, fairly fast, and that's, I think, causing a bit of issue.
We end up cutting some rubber matting to try to make star wheels last year on our CNC, and we found that using a downcut bit, which I think is what you're saying with a compression bit, is that right, Ian? Same thing?
So a compression bit is, so there's downcut bits and there's upcut bits. So downcut bits push the chips into the, in the case of making, wooden board game turntables, it pushes it into it, and then the upcut bit will pull it out. And so the issue with just doing a downcut bit is that means, or I'm going to mix up one of the two ways, but if you just use a downcut, I think like the bottom looks crappy at the end. And if you just use an upcut, then the top looks crappy at the end. So the compression uses a downcut for the top part of the flute, and upcut, or I'm bad at directions, but something along those lines.
Yeah, there's a lot of different options on that. But anyway, but we found that we were tearing out too much and the side looked like crap. And so we used a downcut bit on the rubber, and we were able to cut some pretty nice looking star wheels out of some, I think it was 1/4-inch sheet rubber. We ended up not using them, but it was a nice experiment, and it was cool to be able to cut that on the CNC.
Yeah, having the right bit, especially when you get into aluminum, is super important. I would recommend an O flute bit for that, and certainly solid carbide. I wouldn't even mess around with high-speed steel at all for aluminum with a router. But the bits are kind of pricey. I mean, even the cheap Amazon ones aren't super cheap. If you're getting like an 1/8 inch or a 1/4 inch bit, they're going to cost you a little bit, so you don't want to break tons of them. I've ordered some from a bunch of different places. Ones are on right now. A Manitool is pretty good, but they're not cheap. You get the Amazon ones, these little shiny rainbow coated ones, O flute, 1/8 inch. They've held up pretty good. As long as you don't crash them, they do pretty good. And then another thing for a router, which isn't a bad idea, and we haven't used it much, but this is a tube jig, Aussie boards. So you take your 1 or 2 inch square aluminum. So if you wanted to do like a chassis frame, they just lock in with these little levers. Obviously, you have to have this mounted securely to your machine and indicated in. So when you get into routers, and if you're going to do stuff like this, you're going to have some like general machine tool measuring devices probably to make it work well. So this one would need a dial indicator to make sure that this is nice and straight in comparison to the axis, whatever axis you want to mount it on of the machine. And then like this little Coulson wheel that we're going to be messing with to we'd have to indicate the center, so you would need an indicator that would go on the spinning part of the rotor here, to indicate that center location, because that's what we're gonna need to reference for what we're gonna do with the wheels. But some little add-ons you can get once you get a rotor. But there's a couple other tooling type of things. Be aware what collet you use. These are ER20s, which is pretty common. I get a couple different sizes of those, for sure a 1/4 inch, for sure an 1/8 inch, and maybe something bigger if you want it. But there's a few other little things besides just the machine. Rasmus has had his hand up for a while.
Yeah, I wanted to ask a question because on the Mythic we use the X-Curve Pro, and that one has been really nice. That's not the belt drive, the screw drive thing. Anyway, we've had a lot of success with that, but I was a little curious because that's an MDF wasteboard, and we've been using oil as a lubricant. And so I was curious what the advantages of using alcohol for an MDF wasteboard is.
We chose MDF. We chose the alcohol because the MDF doesn't, or absorbs it, but it doesn't swell unless you like dump a whole bunch of it on it. So we read a bunch in Chief Telfy, and the two fluids people used are WD-40 and the isopropyl alcohol. And the isopropyl alcohol is just more readily available. You can pick it up at any Target or CVS or wherever. You need to use the 97%. But yeah, it's enough to cool the metal in the bit, to remove chips, and for us, it isn't swelling up the wasteboard unless you have a drip that goes on overnight, and we had an issue with that. But
I know we're running short on time here. I'm just going to go over a couple last little things that we use frequently. We have a couple lathes. We have these little Grizzlies. Nice that it came up with a little DRO though, because teaching kids how to do the lathe and how to do all the increments on the handles and stuff is a chore. But these have worked pretty well. They're not a variable speed. So you got to change the gears manually, but they're not bad for the price, I guess. Not a big swing, not a big distance between centers, but not too bad. And then we have the Sharp in the back there, which we've had for ages. That thing's a workhorse. That's variable speed. That thing's really nice. Ben, you got a hand?
yeah, what sort of things are you using a lathe for?
Any kind of little spacers, bushings, turning different shaft diameters down, modifying gearboxes, putting C-clip ring grooves into stuff. Probably not our most commonly used thing, but we use them quite a bit. Even like turning down Chiro tubes, like if you're making standoffs, like I can get it within probably 40 thousandths on a bandsaw cut, but I can get it within 2 thousandths on a lathe or less. So you have a nice even standoff that you can run through there for different purposes, I guess, whatever you can imagine that might be. But these ones are basically tabletops. You don't have to get the bench that goes underneath them, so they can sit right on a table. This one actually, the motor went out on it this year, which kind of hesitates me to recommend it a lot, but a bearing went out in the motor. I'm waiting for a replacement. I have two, so. And then a couple mills. And this is another acquisition part potentially, like this old Enco that we got here is at our local university. And they said, if you can get a trailer and come get it, you can have it. So I did. I got a trailer and I went and got it. It took 3 people hanging off the Bobcat at the school and somebody inside lifting it as to not tip the Bobcat over when we unloaded it. But it's here and it's staying. And it's a pretty nice mill for free. Came with some tooling and vise and collets, and a DRO. And then this is not a Grizzly commercial, obviously, but we've used this one for years. You see there's no motor on this one right now either. We had a bearing go out down into the spindle and replace that, and in the process of getting it back together. But I've used this a lot, made a lot of robot parts, made a lot of parts for classes on here. Bridgeport style knee mill. It's got a power feed in one direction, came with a DRO, came with some tooling, but making accurate parts, you can do a lot more with one of these than a hand drill and a center punch. So that's kind of the equipment. We do have a plasma cutter too. We don't use that for robotics because I never got it to cut aluminum worth of crap. But that's kind of what we use here in Cass Lake. So anyway.
I have a tip for everyone. I'll paste the link in the chat. We have started buying a lot of our in mills from onlinecarbide.com. This was recommended to me by the alumni that Ben was referring to. He's now a full-time machinist as his regular job, and he buys all of his in mills from this place for all of his personal projects. And for aluminum, he's like, you just buy it from those guys. The site looks super sketchy. I went there the first time and I'm like, dude, I don't think I want to put my credit card into this website. But I tell you what, they're super fast. I've been very happy with all of the bits we've got from them. So clearly they don't put their money into their website. They save it, and I guess maybe they pass on the savings to their customers. But we've been getting our emails from here based on that recommendation, and I don't have any complaints.
There might be like FRC then. Website sucks, and everything else works good.
Could be. Yeah, that's a good tip. Finding good quality tooling for this stuff is important if you're getting into routers and stuff like that. So I will definitely be looking them up. Anybody got any other questions? I think there was a lot of good conversation and some other stuff that I'm going to take away, especially on some router things and a few 3D printer things. This is just what we do, and it's kind of changing all the time. But it is game changing if you don't have a good supplier that's going to create machined parts for you to get a router or to get some of these other things that you can make a part, you can design it on the computer, you can make a part that fits. It's going to fit. It's going to do what it's supposed to do. That's huge. So.
Do you have anything else you Jesse, or anyone else wants to kind of close out our session tonight with?
I guess I have one thing. And that's that, because something that Nomothic is realizing is that we don't have a lot of people that actually know how to use the machines. So training is really good. So I just want to bring that up.
Yeah, that's a really good point. And that's true even here. I mean, unless the kids have taken some of my higher level manufacturing classes, they don't necessarily know either. But throughout the course of a build season, they can get some pretty good. And things like a router, I mean, there's different steps to learning that process. They don't have to do the design work, but they can run it. If you get it kind of set up for them, it's kind of having somebody babysit it, and they can kind of see how the machine works. And then you can kind of bring them in from there through the CAM aspect and touching off tools and things like that. Once you get to the manual machines, which is actually, I think, is a little more complex to teach because it's a lot more. It's less done for you, but teaching somebody how to safely run a mill is a thing, and safely run a lathe is even more concerning because lathes can really be hazardous if you're not careful and respect the equipment. So yeah, having a mentor that's able to train a student is important for these things, for sure.
During off season, we run every student through every tool other than the CNC they need to check off. So that becomes sessions that we have the students actually teaching other students, but require everyone to check off at every piece of equipment.
Yeah, highly recommended. Some kind of training, some kind of check off. Just if not for the machine's sake, because you don't want to wreck a $10,000 piece of equipment, but just for liability and personal safety sake, definitely training needs to be like done and documented somehow.
Very good. This has been fantastic. I've enjoyed this session. I think this was a great topic, and I hope everyone else enjoyed it too. Thank you, Jesse. Round of applause for Jesse. This was awesome. If anyone else is interested in kind of leading a conversation or giving a presentation, you can scroll back up in the thread. Lexi posted the sign up form for that. It's also in the email I send out every week. You can find it there. Ian, do you want to give commercial for our topic next week?
Yeah, so next week, we're going to be discussing the game release for Mini Trials. So Mini Trials does a mock game every fall that a lot of teams who participate in these calls participate in, and I think it would be fun to analyze the game as a group. And even if your team isn't doing it, there's still, good experience for analyzing different types of games that even if your team isn't necessarily building a robot for Mini Trials or participating, there's still a lot that can be gained from, going through those steps of strategic analysis and game analysis that I think will be helpful for everyone. And it'll be a day after the game releases, so it'll be new for all of us. I'm excited to see what it's going to be, and I'm hoping it's a shooting game that involves overinflating cubes to become spherical.
That's a good point, Ian. I hadn't really thought about that, but you make a good point that even if your team isn't participating in Mini Trials, going through the design process, the game analysis process of what is going to be key to winning this game, that can be a great exercise for any team. And then you could watch Mini Trials and see what other teams did. I think another important thing for Mini Trials is that the philosophy behind Mini Trials is that you want your new students doing most of the work on the robots as a way to do training. So I think a lot of teams do this, but the way that Nightcrawler approaches it is that we have our new students do most of the design build. We have our returning students sort of act like captains, and we have our captains sort of act like mentors, and the mentors stand back and make sure nobody gets hurt. And so we try to push all those roles up so that we try to get as many new students hands-on to building a robot as possible. And I think the whole kickoff process and that game analysis and design, our students, we got great feedback from our students last year that it was a great way to learn robotics for when you just start joining the team. So I'm looking forward to it. I hadn't even considered that, Ian. I'm really glad you suggested this topic. All right. Any final things before we go?
Thank you, Jesse.
Yeah,
Yes,
thanks everybody for tuning in.
Thanks again,
If you
Jesse.
have questions, let me know. If I have questions, I'll look up some folks on here too. So
Excellent. All right, everyone.
Thank you.
See you next week.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.